Assalamualaikum warahmatullahi taala wabarakatuh. Can you hear me? Oh, okay. I'm sorry, internet today, my internet is not stable. So I just managed to connect now. So we are a little late than normal. Ni boleh dengar tak saya cakap ni? Can you hear me?
Yes, sir.
Okay.
Yes, sir.
All right. So hopefully, if our class, let's say after some time, if the class got disconnected, so you stay, right? Hopefully I can connect again. Because I don't know why, my internet was off. I have it took me a few minutes to reconnect. So let us start with our discussion. Continue from where we left last class. If you recall, last class we were talking about, I left you with that example. Is that right? I asked you to finish up the thing. So let us finish that example. I think I asked you to finish up the visible region, or what was it? Yeah, I think the visible region. We wanted to find the visible region. Yeah, given the problem here, okay, you have the problem here to maximize the objective. 3x plus 5y equal to, yeah, we use F or C, subject to the constraints for x plus y, all these things. So this was our problem. Now, what I wanted you to do is to draw this on the same graph, get the visible region, the corner points, and then we're going to find the solution. So I think that's where we left. So now, let's finish this up. So if you look at that problem, what are the corner points? So find the corner points first. No, not corner points, I'm sorry. Find the intercepts for the equation. For the equations corresponding to the inequalities. And then we get the visible region. After that, we get the corner points. Okay, I didn't do this question. If I do that, I will get the answer right away. But I didn't do it. I didn't write it down. Actually, I solved this problem with the other class, but I didn't write down the solution. So we will have to do this. Okay. Okay. Get me the intercept for those equations. Okay, what is the intercept for 4x plus y equal 20? Apa dah? So that we can do this quickly. Okay, subject to 4x plus y equal 20. And then I have 2x plus 3y less or equal 50. 4x minus 7y less or equal to 48. Okay, now, what are the intercepts for the 4x plus y equal 20? Apa dia intercept? Anybody who get it? Can you just tell me so that we can do this quickly? Apa?
X-intercept is 5.
So you have, right? You have the 4x plus y equal 20. X-intercept 5. So 5, 0. Okay, y-intercept? Apa?
0, 20.
0, 20. Okay, the other one, the next equation. 2x plus 3y equal to 50. Apa? 0 apa? X-intercept?
25.
25. 0. Okay, y-intercept?
16.67.
16.67. Okay, good. Okay, last one. Last one, mula-mula berapa?
12.
12, 0. 12, 0. And then the y-intercept negative 0.
6.86.
6.6. 6.67 juga.
6.86.
6.86. Okay, 6.86. So, 48 minus 7. So you have a negative value there. Okay. So now you draw the graph. Okay, we draw the graph on the same. I mean, you draw the inequalities on the same graph. So let's continue from here. So what you do now, you find. Okay, I want everybody to work out for the intercepts. I do that because I don't have the time. So let's draw this. You have x and y. Now we can use 5, right? We can use 5. So here 5, 10, 15, 20, and there's 0. You got 5, 10, 15, 20, and this is -5, this -5. So for the first equation, you got 5, 0 be somewhere here, and then 0, 20, you get that one. All right, so 0, 5, 0, 5. So you connect the points. Now, my line is off a little bit, all right? So that's 5 also. So you label that for x plus y equal 20. Now you want bigger than. Where is it, up or down?
Up.
Up. Okay, for those who do this, you should know, okay? We do together. For those who don't do, okay, just keep quiet. All right, you have for x plus y bigger or equal to 20. It's up. Now for the second one, well, you've got 25 be somewhere there. And then 0, 16 be somewhere there. So I make the connection here. All right, so you got 2x plus 3y equal 50. Now you want less than. So where is it, up or down? Of course, you know you have to test with the test point. So for those who have done it, up or down?
Down.
Down. So you get down. All right, so those points are below the line. So that is our inequality. So you write down here, 2x plus 3y less or equal to 50. Now for the last one, I have 12, 0. 12, 0 is somewhere here. And then negative 6.68 is somewhere there. So connect the points. We get the equation for x minus 7y equal 48. Anyone less than? So less than, up or down?
Down.
Huh? Down to up. I mean, up means above the line or below the line.
Above.
Above lah. Okay, so you'll see that will be the region. So that is the third inequality. So where is the feasible region? As you can see, the feasible region will be this area, the triangle. So you label that point A, B, C, and of course, first you need to label that feasible region. Okay, so feasible region bounded by that point up to here, up to that one. All right, so label this point A, that point B, that point C. So you have to find. Now the next part is you have to find the points. So determine, okay, find A, B, C. Okay, so if you look at A, for example, A, it's the intersection between what? 3x plus 2x plus 3y, I'm sorry. 2x plus 3y equal 50. Okay, and that line, which is 4x plus y equal 20. So using the system, you find it. All right, B, C. Now, anybody who has found the points, just tell me now. Anybody has found the point? Like, what is A?
116.
Okay, 116. You got B, you got C. Okay, so you have to find it. Okay, work it out, and then we found that. Okay, after you do the system of equations, you solve it. Now you got the point A equal to 116, and then so on. Now what you do, we table it. Okay, put it in a table. So you have the points here, not just the point, it's corner point. So call it CP, corner points. And then what you do next here is the objective. Okay, now point A is 116. Point B, what?
5.875.
Can you repeat? I was not clear. I cannot hear.
5.875.
12
And
point
negative
12.85.
5, sir.
85.
No.
No. Okay. Say it louder. Say it louder.
5.875.
Okay. 5 point. Okay. Wait. 5.87 Kita guna, we use up to 2 decimal point je lah. 5.87. The Y?
Negative 3.5.
Negative 3.5. Is that right? Anybody get the different answer? And anybody else get a different value than what she had? So if you look at the graph,
No.
sama lah tu, negative 5 point something, negative 3. So that looks reasonable. Okay. So now point C. Okay, what is point C?
19.4.
19?
4.
4. Okay, 19.4. Anybody got different value than that thing? So you have here 19.4. Yeah, look, okay, quite close to 20. So you got those points. Okay, what you do next is that you put into the objective. Okay, the objective is we use f equal to 3x plus 5y. So that is the objective. We substitute. Okay, we substitute the points, each of the corner points, into the objective, and then we get the value of the function f lah. So now we do it one by one. So first point, I got 3 multiplied by 1 plus 5 times 16. Okay, what is it equal to? 5 times 16 dapat how much? And then you add to 3. What do you get?
83.
83. Okay. Now you put in the second point. You got 3 times 5.87 plus 5 negative 3.5. Okay, apa?
0.11.
0.11. And then you got the last point, 3 times 19 plus 5 multiplied by 4. You got 20 plus 57. Berapa ni?
7.
Okay, 7, 7. So now we look at the values. We just observe the value and which value solve the problem, okay? Which value is the solution to the problem. Now recall the problem is what? The problem was we want to maximize the objective, okay, which is 3x plus 5y equal to f subject to the constraints. So the problem here is to maximize. So maximize means you look at the maximum value, all right? You look at the maximum value, and then what is the point that give you the maximum value? So we just observe. So this will be the one. Okay, 83 is the maximum value of the objective. And then the point that give you the maximum, which is 83, is point A. So we just say that, describe the point. So you can say the maximum value of the objective, okay, of f equal to 3x plus 5y, all right? Given the constraints, you don't have to write the constraints, but banyak. Okay, given the constraints is 83. And it occur, or the point, all right? The point that gives you 83, or we say that it occur at where? At the point x equal to 1, y equal to 16. Or you can say the point, okay, or we can say also the point that give you the maximum value, okay, the point that give the maximum value is 116. Or you can say x equal to 1, y equal 16. Okay, so that is described. Okay, all right. Now, suppose the problem is to minimize. Okay, let's say the problem is instead of maximizing, we are going to minimize. So suppose it is a minimizing problem. So you want to minimize, okay, I just put a bracket here. Minimize the objective subject to the constraints. Everything will be the same. Okay, the method will be the same. You want to get the constraint, and then you get the feasible region, you get all the corner points. The only difference will be when you look at the table, all right, the table of the corner points, and you look at the value of the objective at each of the corner point. That's the only difference. Now you want to do what? You want to find the minimum point. Okay, what is the minimum value of the objective? So if it is a minimizing problem, now what is the minimum value? Minimum value will be 0.11. All right. So you say the minimum value. So now you what conclusion? All right. You do your own conclusion based on that point. You say the minimum value of the objective given the constraint is what? 0.11. It happened at, or it occurred at x equal to 5.87, y equal to negative 3.5. Or the point that gives us the minimum value to the objective is x equal to 5.87, y equal to negative 3.5. So whether it is a maximum or minimum, the method is the same up to the table. Okay, the only difference will be if it is the maximum, you look at the maximum value. If it is minimum, we are looking for the minimum value. Okay, any question? All right. So if there is no question, let's look at application. So we are going to look at application of the linear programming problem. That means you want to maximize objective or minimize the objective given the constraints, which are inequalities. So first of all, I would just like to give you the outline. All right, the outline of the method. So the method is what based on what we learned today and on Wednesday last week. This is the method. So here, when you look at application, first of all, of course, you get the idea of what the problem is. Okay, what the problem is about. Is it maximize or minimize? and then you have general idea of the problem. What you do is summarize the information. All right, summarize information. This is what like we were doing last week. Okay, just give the general information without numbers. Okay, what is the company? What is the product? What are the inputs? Things like that. All right. So you summarize the information, and then secondly, what's the problem? Maximize or minimize? So that will be the objective. So when you know it's maximizing, minimizing, you know what is the objective. All right. What is the objective of the problem? Normally, from the objective, you know the variables. Okay, so you assign variables x, y. What are they? Okay, and from there you know what are the constants. So number 4, from here you know the constants or the constraints. Okay, constraints or the constants. That means the one that is the limiting factor. Constants. Okay, that will be the limit. Okay, the limit value. So you know what they are. And then number 5. You table the information. Okay, you table the variables and the constraints. Okay, and from here, okay, from there you will get what? You will get the inequalities. So from the inequalities that will form the formal constraints. So when you get the inequalities, and then from the objective there, you will get the objective function. So next you get the objective function. And objective function is linear function. So you got objective function, then you are done. So normally or sometimes you can get the objective function here. Okay, when you know the objective, you get the function right away. So this step here is just for a guideline. All right, it shouldn't be in order. You can get the constraints first, or you can get the objective first. That will be fine. Unless the real thing is we should get the table. Okay, you should get the table for the variables and the constraints, and then from there you can get the inequalities. And then lastly, you formalize the problem. Okay, formalize the problem means you state the problem. Maximize the objective subject to the constraint. So that means you formalize the problem. So this is the outline of the method. After you have done this, everything will be normal. Okay, everything is the things that you already know. In other words, we will solve the problem according to the method that we already learned, the graphical method. The only focus or the only new thing here is the method of getting the information together and then coming up with the inequalities and the objective. So, any question? Anything? Okay, good. So now let's go to example number 2. So in order to get the idea, for this kind of thing, we look at example number 2 on 4.2. Now, if you look at that example, we already have done the inequalities. Okay, last class we did the inequalities. So today, all right, we will just add on. Okay, add on. In other words, you want to find what is the objective, and then what is the variables. I think we already know what the variables are. So let's go back to that example. I think we did that example. The corner points. Did we do that example? Oh, okay, here we do that. Okay, so we already have that problem. From the last class, you already know that X is the number of acres of corn, Y is the number of acres of soybean, and we have already the constraints, and you form the inequalities. So that part we know. Okay, so now let's go back. Let's go to example number 2. What is the objective? What is the objective here? So you read the thing. Then what is the objective? what is the purpose? What do you want to maximize, and what you want to minimize?
Maximize revenue.
No, not revenue. What is it?
Maximize profit.
You want to maximize profit. So objective here is maximize profit. So that will be our objective function. So the profit function, P, okay, equal to AX plus BY. It's linear function. If it is revenue, okay, you maximize revenue, then the revenue will also be the something like this, all right? So the objective is always linear. If you want to minimize cost, okay, then the C will be just also AX plus BY equals RX plus BY, linear function. So if you look at this thing here, A and B, okay, are the constants that you need to fill in. Okay, so you need to find that AB so that you have a linear function with the constants. So AB are the constants, and you need to find that AB. Normally it will be given now. Okay, and this AB are what? Are the value of the objective. Okay, the value of the objective per unit. Okay, per unit value of the objective. In other words, if you are looking at the profit, A, okay, is what? Is profit per unit, okay, of X. And B normally is the profit per unit of Y. Okay, so if it is revenue, then what is A and B? A is what? A is the revenue per unit for the X. B is the revenue per unit for the Y. If it is cost, then A, what? A is the cost per unit, average, okay? Cost per unit of the X, and B is cost per unit of the Y. So AB normally, okay, is the objective, not the objective function. It's the objective of the problem, all right? The thing that you want to maximize or minimize. The objective per unit, okay, of X, and objective per unit of Y. So it's not cost like variable cost and fixed cost, of course, you know, that will be the concept. But for this problem, we are looking at just cost per unit of X and cost per unit of Y, or whatever it is. If it is profit, then profit per unit of X, profit per unit of Y. So in short, it will be what? It will be a measure of the objective per unit, okay, of X, and objective per unit for the Y. So your objective per unit of the Y. Okay, all right. Now, if you look at that problem, what is the profit? What is the profit per unit for X? Which is what? Which is the con in acres. So what is the profit per unit for the con?
240.
240. So it is given. So therefore, okay, our profit will be equal to 240x plus 160y. So that is our objective. Okay. So the constraints, all right, we already have. So the problem now is to maximize the profit as per given here, subject to the constraints. So now you state the problem. So that's why I said to formalize the problem. So the problem now becomes what? Problem now is to maximize the profit, okay, equal to 240x, okay, subject to the constraints which are, okay, subject to the constraints which are what? Which are already given. So you go back to that page that you have earlier. So you just look at the book. You have the land constraint, which is x plus y less or equal to 6,000, and so on. All right, so x plus y less or equal to 6,000, and so on. Okay, and of course, in application that we include x bigger to 0, y bigger equals 0. But sometimes in application, you don't need that because we understand already. Okay, all right. Any question?
No, sir.
Yes, other question? Yes, yes, okay.
Understand, sir.
Okay, good. So I would like you to do one question. Okay, so go to the book. Go to the book on 4.2. 4.2, I would like you to come up with the formulation of the problem. So 4.2, go to question number 28. Okay, question number 28. Now, this one would be in class homework. I want you to do this. Put on a piece of paper, all right, put your name. Now, this is individual work, all right, not group, because you do it right away. Now, name your metric number, okay, and then you submit to classroom. I will put assignment number 1 afterwards, okay? As of now, belum lagi lah. So classroom, you submit to classroom. Put your name, metric number. What I want you to do is go to question number 28. I want you only to do the first part, okay? To do the first part, not the solving of the problem, just to come up with the problem. So I want you to get the variables. Okay, what are the variables? Summarize the information, okay, and then table the information. After that, the problem. So basically, I want to do up to here, lah. Okay, up to here from the beginning. So that for question number 28. Okay, I give you 5 minutes to do it now, and then I will discuss with you. Okay, so I want you to try this. Okay, whether it's wrong or it's right, that's fine. You don't know, you don't go and read anymore. Okay, now it's not the time to read. Now it's the time to do. If you go back and read, nothing is going to be done. So I want you to do this problem. Okay, up to this point. After this, I will discuss, and then you submit to me whatever you have. Okay, all right. Okay, do it now. I give you 5 minutes.
So the question is about Sierra Woods products.
The question is on, yeah, if you have a different edition of the book, it's on the Sierra Wood. Sierra ke Sarah ke entah. Sierra Wood. Okay, so make sure that's the problem. If you have the problem on a different number, then do that problem, not the number, okay? Not the number. That's the problem. The problem is question number 28 based on 11th edition. So if you have a different edition, different number, okay? All right, thank you. Saya pun tak ingat dah. Okay, okay, good. Okay, anybody has a problem? If you have a problem, let me know. Because after this, I will go through with you. And if you have a problem, okay, we can discuss now as we move on.
Sir,
Yes.
should we draw the graph?
No, no, no. You only do up to here. Okay? You only do up to the problem. That means you maximize what is it, what is the objective, subject to the constraints. That's it. Okay? You don't need to do anything else. Okay? I don't want you to solve the problem. We just need to set up the problem. Okay? That's why I give you 5 minutes. If you want to solve the problem, then it may take 20 minutes or 15 minutes. So we only need to set the problem, okay? To formalize the problem, not to solve. So only up to here, like I said earlier. Okay. Okay, got it? Okay, what are the variables? I mean, what is the problem about?
To maximize the profit, sir.
The problem here is to maximize profit. Okay, so you can see the problem is to maximize profit. From there, the objective is what? Profit. So normally from the objective, you can get the variables because they will ask you how many of what, how many of what, or the variables to maximize the profit or to minimize cost or, the objective. So from there, you will get the variables. So if, you look at that objective, then what are the variables? Okay, so you get the variables. All right. So before that, what is the problem about?
The limitation of labor and wood.
The limit will be the okay. We go. You go from the beginning. Okay, we go from the beginning. We don't go from the end to the beginning. You start from the beginning. What is the beginning of the problem? Okay, give me the summary information for those who are doing it or you have done it. What is the problem about? Basic, okay, basic info. Of course, you don't have to do this in your problem, but get the basic info. What are they?
Profit.
Before the labor and before the wood, what is it about?
Maximize
Before the profit, what is it?
Manufacture. Workers.
This is manufacturing. Okay, so you think that is what the company, the Sierra Wood. Okay, the Sierra Wood is manufacturing what?
Rocker and bookshelf.
Manufacturing two products, which are rockers and bookshelf. Okay, so normally we start with the beginning. We don't, of course, you can start with the end, but the end will come later lah. Okay, so the company produce this thing, and what? In order to produce those products, what do they need? They need labor and wood. So these are the inputs, and these are the outputs, the products and the inputs. And of course, after that, the objective is to maximize the profit in terms of, the X and Y. So therefore, from there, X is what? X, you can put X as the rockers in terms of units. And then Y is the number of bookshelves, also in units. They don't give you the units. They say how many, okay? How many units. So that will be just in units. So now rockers and bookshelves. And of course, in that sense, once the rockers and bookshelves are the variables, so these are the labor and the woods are the constants or the constraints or the limit. All right. So now you can tabulate the information. Okay. So if you table the information, you put rockers and then bookshelf. And then you have the labor and wood. And of course, there's the X, that's the Y. Now, the Y is not just rockers, it's the number of rockers. Okay, just like the previous example, X was not corn, it's what? It's the number of acres of corn. Okay, so you get the unit, and then that labor. What is the unit for labor? Unit for labor apa dia?
Hours.
Hours. So the limit unit for the labor is hours. The wood is in feet, yeah. Feet, what feet? So already the units. So now you relate the variables to the inputs, which are the constants. So in order for us to produce 1 unit of rocker, it requires 4 hours and 8 feet. So here 4, 8. And then to produce what? Bookshelf, how much is required? 3 and 12. Okay, so now when you summarize the information in the table, then you can get inequalities systematically. Okay, now what is the limit for the labor? At most 930 hours. Now at most, what is it? Bigger equal to or less or equal to?
Less or equal.
Less or equal to. At most, it can be, that will be the highest. It can be lower. Okay, cannot be more than that. And of course, for the wood, it's also at most, you have 2,400 feet. So from here, you get the inequalities. Okay, and then the objective, is a profit equal to AX plus BY. So the A is not, A is simply profit per unit of the variables. There's not profit from selling. You don't need the price, okay? So profit is equal to what? 30 and 42. So you put in 30x plus 42y. You got this? You got that? Okay, now you state the problem. Okay, put the problem statement. That means I want to maximize the profit, which is given as that function, subject to, okay, you list down the inequalities. So here you got only two inequalities, correct? What are they? 4x plus 3y less or equal to, and then you got 8 plus 12y equal to the number. Okay, all right. So if you do it wrong, okay, just do the correction. Don't care, okay? No, don't worry whether you get it wrong or not, okay? Because now it's just to practice. You make the correction to you, okay? So you make, if you got it wrong, make the correction by yourself. So you grade yourself, okay? You grade yourself. Write down the correction, okay? Don't erase, okay? Just write down the correction so that you know where you went wrong. So after you do all the correction, if you got everything right, that's good. If you got everything wrong, that's fine. Do the correction. That means you have to study more, lah. Okay, if you got all wrong. So you give yourself 5 points. Now everybody get 5 points. Okay, so whether you got it wrong or you got it right, you do the correction, you get 5 points. So that 5 points, you put it on the first page, all right? The upper right corner. Okay, so put that number upper right corner so that it's easy for me to record down. Upper right corner. Make it bigger, okay? Don't make it too small. Put your marks 5, and then after this, I hope I can do it by tonight, okay? So you just keep your work, and then when I put it in the classroom, I will put a message in the WhatsApp, and then you submit. Okay. Now this homework is only for those people who come, okay? Who come to class today, 58 people only. All right. If your friend don't come, if they want to do this homework, they can do, but don't submit. All right. If they want to do, they go ahead do, but no submission. This is only for those people who come to class. All right, who come to class as of now. I mean, when I assign the problem lah. Okay. Any question? All right, good.
So sir,
Yeah.
so the answer until yang listing up the inequalities je.
Yeah.
Okay.
So until that thing.
Thank
Until
you.
that. Okay. Until ni lah, state the problem, maximize the objective, subject to the constant. So that's it. Correct? That means we just need the beginning of the problem. All right. So your homework is, okay, your homework or assignment, finish up the problem. All right. So you finish up the problem, but you don't have to submit to me lah. Okay. You finish up the problem. That means you draw the inequalities on the same graph, get all the corner points, and then substitute the corner points into the objective, and then you get the solution. Okay. So you finish this up on Monday. No, on Monday, Wednesday. Wednesday nanti we will check the solution. Okay, check the solution. What is it? All right. Okay, good. So that will be the end of chapter number 4. That's it. Okay, we are only doing the graphical method, and then for the linear programming problem, it's also the graphical method. So it's only 4.1, 4.2. So this topic is fairly short. All right, so it's easy because it's based on linear functions. And just, we need a lot of work, but the work is simple work, all right, nothing difficult. So I give you last time, number 25, 27, 32, 32, and then I give you 39, 39. Yeah. or you can add. You can do one more if you want, 42 and 28. I give you today, right? So you do a few of this, all right? You don't have to do all, do a few, You can do maybe 25 and then do 32 and then do 42. Maybe 3 out of 5, that would be good. Do one maximize, and then one minimize, something like that. Okay? All right. Okay. Any question? Anything? Okay, we are done with the linear programming. Okay, inequalities, linear programming, finished. So now we move on to a new topic. Now this new topic is, if you go to the course outline, after you do the linear programming or the inequalities, we are doing the chapter 9. Okay, chapter 9, which is on the derivative of a function. Okay, derivative. So that would be chapter number 9. Now, if you look at chapter number 9, the first part of derivatives. If you look at chapter number 9, 9.1, they discuss about the limit. And then 9.2, it's the continuity of the function. And then the definition for the derivative is on 9.3. So these are conceptual part, theoretical part. So 9.2, 9.3 to a certain part, these are all concepts, quite detailed, the concepts. It's a mathematical concept. So we're not going to do that, okay, because I don't think, when I look at the time, and then our purpose is not to look at all these mathematical concepts. So what I want to do, I will just look at the idea of derivative, okay, and then how we are going to use it for our purpose, okay. So 9.12, don't worry, 9.2, but 9.3, maybe a little bit, okay. So you don't need the limit, you don't need continuity, but we know that for the function to have a derivative, you need the function y equal to f of x must be continuous. So don't worry about this, okay? We assume this one, okay? We assume. That means if you want to do the derivative, we assume the function is already continuous, all right? So you don't have to prove the function is continuous or not. We just assume, okay? Continuous function. So therefore, most of the function that we do, we can differentiate. Otherwise, we don't ask to differentiate. Okay, all right. So we just assume the function is continuous and there is a limit to the function. So we don't worry about those. We just worry about doing the derivative. Okay, now, what is the derivative? So consider a function. Now, when you do the derivative, this part, we are looking at a more general type of function. So it includes linear, but more often, most of the functions are non-linear. Okay, non-linear meaning the curve is not a straight line. So non-linear means your function would be something like this. Okay, so that is non-linear. So most of the function that we come, and in this topic will be non-linear. Linear, of course, you already learned in chapter number 2. So we do derivative, and most of the function will be general function, all right? Include linear, non-linear. So let me clean it up. What is the derivative? Okay, derivative is the idea is based on the concept of slope. All right, the derivative is based on the concept of slope. So we say a function y of f(x) has a derivative, or we say the function y of x is differentiable. So if Okay. If y has a derivative, that means we say we differentiate f. We differentiate f. Or I think y is the function. We differentiate y. Or of course, you can also say f. So we differentiate y or f. Then what you got? You got the derivative of y. The derivative of y or f. So in other words, if y is differentiable, differentiable, then y has a derivative. Okay? Normally, these are the words that we use. You differentiate y, or is y differentiable? Or you find the derivative of y. All right? So y, okay, I mean the derivative is also a function. All right? So if you look at this idea, y is a function, and then you differentiate y, you get the derivative. And that derivative is also a function. It's just like us, you know, you and I mean your parents and your mom and your dad, you know, they got married. They are what? They are people, human, and they get you, give birth to you or to us. So they are human. We are also human, but we are derivative of your parents. Okay, you are derivative of your parents. Your parents is human. We are human, but we are derivative of your parents because why? Because we come from them. All right. So derivative, you think of it as the offspring of the function, the children of the function. Okay. All right. So something like that. So you have the function y, you differentiate, you get the derivative. So differentiate here and the derivative. What is the difference in usage? What is differentiate? Differentiate, and then the derivative. What is the difference in terms of the language used? What is differentiate then by you know by the usage of the term and the derivative? Anybody? Differentiate is the process. Okay.
Changing, right? Changing.
Differentiate is the process. It's the verb, the thing that we do. All right. Derivative is what? It's the object. So it's a noun. Okay. Derivative is the function. It's the object. It's the noun. Differentiate means the process of doing it. So it's like a verb. Okay. So that is in terms of language. Okay. All right. So next, we'll look at notation. How do you write it? Okay. So now you know y is a function of x. We write the derivative of y as the following. So the derivative of y, that means after you differentiate y, we denote by y prime equal to f prime of x equal to dy dx equal to df dx, or just f prime. So these are different notation for the same thing. So that comma on the top, we call it y prime. Okay, so the word prime, here f prime, here is f prime. So when you see that comma there, we read it as prime. So the derivative, you can say f prime, y prime, dy dx, f df dx, and f prime. So normally we can write here, you know, this one is the easiest way to write. Now, when you got dy dx, that relate to the slope, because by writing dy dx, that relate to the slope. Okay, this one we discuss later. Okay, so that is notation. Now, next, okay, next, as I said earlier, the derivative of y prime, is also a function, right? So y prime is a function of x, all right? In other words, f prime of x is a function of x, and dy dx, f prime is a function of x. Okay, all right. Now, next, this is the one that we need to, to understand the concept that we use as of now for this chapter. So when you take the derivative of the function, so the derivative, all right, of y, you have y prime equal to f prime of x. Now this will give you, okay, the expression will give you, will enable us, will give you or will enable us to determine or to find the slope, okay, the slope of y, of the curve, okay, y equal to f of x at any point. So that's where the derivative is related to the slope. The derivative that we get from the function, all right, will enable us to determine the slope of the function at any point. So derivative, sometimes we call it the slope at a point. Okay, slope at a point. Okay, now what does it mean? Okay, in order to elaborate this, we will go back to the concept of slope. All right, go back to concept of slope in chapter number 2. Okay, what is the idea of the slope from what we learned already in chapter 2? For linear function, y equal to mx plus b. Okay, what is the idea of slope? There.
The changes of y
The change of y.
divided by the changes of x.
The slope m, all right, equal to delta y over delta x, change of y per unit change of x. So this is what we know. Okay, we know this already, and we just get up from there. Y equal to mx plus b for the linear function. You know the m is delta y over delta x. Okay, and if you look at the graph, given the straight line, it's the change of y over the change of x. So you get the slope equal to m. Okay, all right. So now let's look at a nonlinear function. Okay, for nonlinear function, the line is not straight. Okay, the line is curved. I mean, you get a turn somewhere, and upward turn, leftward turn. So let's say you got a function like this. Okay, y equal to f of x. Now for this curve, let's say we use the slope formula here. Y equal to m equal to delta y over delta x. And you take 2 points, okay? Let's say I take 2 points here. I take 1 point, I take a point here. Oh no, I want it to be a positive. Let's say I take a point here, all right, and that point over there. Okay, so this is x1. Call that x2. Okay, so x1 you have f of x1 somewhere there. F of x2 will be there. Now, what is the change in y? And what is the change in x? The change in x, okay, this is y2, that is y1. So if I use the slope m, all right, the change in x is what? Change in x is that. Is that right? So that is the change in x. And the change in y is here. Oh no, change in y is going down up to that. Okay, change in y. So that is the change in y. So the change in y divided by the change in x, what you get will be what? Will be the slope of the straight line. Slope of the straight line connecting the 2 points. That is the slope. Okay, you divide delta x, delta y by delta x, you get the slope of the straight line. Okay, that's come from chapter number 2. Okay, now is the slope m, the straight line, which is the slope, is it the same as the actual curve?
No, sir.
No. Okay, between x1 to x2 is not a straight line, it's a curve. Right? So if you use that formula delta y over delta x, you get the slope of the straight line, but what we are dealing with is the curve. So you need a better, okay? This one, not good. Of course, you can do that, but not good, okay? Not good measure. So you want to find a better measure, okay? A better measure. So that's why we go and use the derivative. So you want not good measure, you want to get it better measure, okay? So what we do is this. We make the delta x smaller. Okay, so delta x, you make it smaller. Okay, smaller and smaller, that means that will approach 0. The delta x will be very, very small. Okay, and of course, from the smaller the x, you just follow what is the delta y. Okay, all right. So let's do that. If I make the delta x smaller, suppose it will be from x1 to x2. X2 is here, so x3, somewhere x3 is here. Okay, let's say x3 over there. I put x3 here. Okay, so that's split. And then x3 over there. The value of x3, fx3 will be somewhere here. All right, so you got the change in x, okay, the change in x divided by the change in y. So that is the delta x, all right, divided by the delta y. Okay, delta y. So very, very, very small, not good. So I think I don't use that one because we cannot see. So I change another value, make it something that you can observe. Kata here, right here. So let's say x3 is there. Okay, so the delta y now will be that value. So that is fx3, delta y. So the delta y is equal to what? Delta y is, this is x1, fx1, so that is the delta y. Okay, what is delta x? Delta x is this thing here. All right, so the slope will be something like this. The slope would be so that is the m. Now, if you look at this smaller change in x, that will correspond, of course, to smaller change in y. All right. So you get the ratio delta y of delta x, you get the value m. Now you compare this m to the curve. And you compare the first m to the curve. Which one is better? Which one is closer to the curve? The second slope or the first slope?
The second one, sir.
The second one, no? Because second one, you see the straight line m, it's closer to the curve. You know, so as you make it smaller, the change in x, you see that already. Okay, you see that the straight line, which you got for the slope, is closer to the curve. So it's better estimate than the one that you have before. Okay, because the one that you have before is too far from the curve. So it's not a good one. All right. So what you do, you continue, make it smaller and smaller and smaller until you make it very small, as if it is approaching 0. Okay, then what happened? Then you will see that the slope will just be a straight line that will just touch the curve at x1. So now that's the m. So you make it as, as x very small approaching 0. What you get, will be just a straight line, just touching the curve at x1. So I will magnify the curve. Okay. X1 tu kat mana tadi? X1 is somewhere below the axis. So X1 is somewhere like that. Okay, somewhere here. X1 is somewhere here. Okay. So as you make it smaller and smaller, all right, as the delta X makes smaller, approaching 0, you will see that the slope, the slope is just what? Is just given by the straight line. That's it. It's given by, okay, the slope given by what? Given by the slope of the straight line. Okay, straight line just touch. Okay, just touch. Now, when we say just touch, that means the line is tangent to the curve. Just touch y at x1. So just touch there. And it's tangent. Okay, just touch means tangent. It's outside, just touching the curve. So that is the slope at the point. Okay, so we say that it's the m is the slope of y at x1. So we call it slope at a point. Okay, slope at a point. So we can use, or we can find that, okay, using what? Using the derivative. So by using the derivative, we can get the slope at the point. You understand? So it's the slope of the straight line just tangent to the curve. Okay, just tangent to the curve at that particular point. So we can get any slope, all right? You can get the slope at here. Okay, the slope at that point, let's say x equal, this one is x4. Okay, now what is the slope at that point? So it's just the slope of the straight line, just tangent to the curve, like that. So that is the slope. Now what is the slope here? Say x2. It's just the straight line, tangent to the curve at that point. So that's the slope. What is the slope here? What is the slope here? Just tangent. Okay. So now you can see here the slope at each point for nonlinear function, they are not the same. Okay. The slope at x1 is not equal to the slope at x2. It's not equal to the slope x4. All right. So the slope is the slope of the straight line, which is just tangent to the curve at that particular point. Okay, any question? So slope here. So to get that slope, okay, to get the slope, we can get it from the derivative. So the derivative will give you the slope. The derivative will enable us to find that slope. And of course, as you know, the derivative is y prime of x, not y prime of x, it's the y prime. It's the derivative of a function. For y is equal to f of x, the derivative is y prime. Okay, so the derivative will give you the slope at the particular point. Okay, any question? So that is the idea, okay? The idea for us now. So how do you get the derivative? Okay, how do you get the derivative? Of course, if you do it, it will be difficult lah. So we are going to use certain formula, okay? The formula will be given, life will make it easy for us. So we just remember the formula, how to get the derivative. For example, let's say you got y equal to 2x squared plus 5. Okay, this function here, how to get the derivative. Okay, so to get derivative, we are given formulas. So we are going to use, or we're going to learn, we're going to summarize the formula next class. All right, and then once we have the formula, we will look at an example, we get the derivative and see how you find the slope. Okay, the slope at the point. All right, any question?
No, sir.
Okay, good. So if there is no question, I think I will stop here. Okay, now don't forget, tonight I will put the assignment number 2 on the classroom so that you can submit. All right, you don't have to submit tonight. You can submit tomorrow. Okay, but as long as only those people who come today, okay, who come to the class, you are the one that can submit. If you don't come, don't submit lah. All right. So that's it for today. Any comment, anything? Okay, I
No,
take a
sir.
longer time because my internet was problematic at the beginning. So I'm sorry, take a little bit longer. So I'll see you again Wednesday. Have a nice day and understand the concept. All right, understand the concept as the slope at the point. So I think this one you can read in 9.3, 9.4. Okay, so for more information, 9.3.4. All right. Okay. So I will continue. I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you,
Okay,
sir.
sir. Thank you,
Assalamualaikum,
sir.
sir.
Thank you.
Sir.
Have a nice day.
Salam, thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Okay, thanks.
Thank you, sir.
Sir.
Assalamualaikum.
Yes.
Sir, can I get a confirmation for assignment 1?